Students, today we are doing paper 4 of February-March from the year 2024. Let's start. Question number 1. Iron ore contains iron oxide, Fe2O3. A blast furnace is used to extract iron from Fe2O3. Some equations in the blast furnace are given. Equation 1, carbon plus oxygen gives carbon dioxide. Then equation 2, we have calcium carbonate. It's decomposing into calcium oxide and carbon dioxide. Then equation number 3 is that calcium oxide is reacting with silicon oxide to form calcium silicate. Question is, equation 1 shows the combustion of carbon in the blast furnace. Name the substance which provides the carbon for this reaction. With the substance which provides the carbon for this reaction, in equation 1, you can see that the carbon is reacting with oxygen. It is burning in oxygen. So which substance provides this carbon in the blast furnace? The substance is called coke. So we add coke in the blast furnace as a raw material and it provides carbon for the reaction. State the purpose of the combustion of carbon in the blast furnace. Now, the combustion of carbon provides heat to the blast furnace and increases the temperature of the furnace. Iron 3 oxide in the ore is converted to iron when it reacts with carbon monoxide in the blast furnace. Calculate the percentage by mass of iron in iron oxide. Now, in this iron oxide, in the compound, we have to calculate the percentage of iron. We have the formula to find out the percentage by mass of any element. We will calculate it by doing the mass of elements in a compound. Mass of that element in a compound divided by the MR of the compound, the molecular mass of the compound, multiplied by 100. So in this question, the iron is Fe2, Fe into 2. And then we'll calculate the MR multiplied by 100. So the iron mass here is iron Fe2. So iron's mass is 56 multiplied by 2, which is 160. Iron mass is 160. So the numerator will be 160 divided by the MR of Fe2O3. So Fe2O3 is 56 into 2 for iron plus oxygen 16 into 3. That's how we calculate the MR, and the MR comes out to be 1. MR comes out to be 160. So MR is 160 and the iron Fe2 comes out to be 112. So in the numerator, we will put 112 divided by the molecular mass of the compound is 160 multiplied by 100. And the answer comes out to be 70%. State the name of the iron ore which consists mainly of iron oxide. So iron 3 oxide is present in the ore hematite. Describe how carbon monoxide is formed in the blast furnace. Now, carbon monoxide is formed in the blast furnace by the reduction of carbon monoxide. Reduction of carbon monoxide. Carbon dioxide. See, in carbon dioxide, when we reduce carbon dioxide, reduction means removal of oxygen. Reduction means removal of oxygen. Now, when we have carbon dioxide in the blast furnace, this carbon dioxide reacts with carbon to form 2 moles of carbon monoxide. This carbon, which reacts with carbon dioxide, removes the oxygen from carbon dioxide. So when it removes the oxygen from carbon dioxide, this is called reduction. So by the reduction of carbon dioxide, we will get carbon monoxide. Write the simple equation to show the reaction that occurs when iron oxide is converted to iron in the blast furnace. So this carbon monoxide, which is produced, the carbon monoxide, which is produced here, formed by the reduction of carbon, this carbon monoxide acts as a reducing agent and it reduces iron 3 oxide. So we have Fe2O3. It reacts with carbon monoxide to give iron, plus this carbon monoxide, it takes the oxygen from iron oxide and forms carbon dioxide. For the balancing, iron is 2, so we'll write 2 here, and for in carbon monoxide and carbon dioxide, the carbon is 3, 3. So this is the full equation. Next question, name the chemical process which happens to iron in the iron oxide when iron oxide is converted to iron in the blast furnace. So what is happening here to the iron oxide? It is getting reduced. So the process is reduction. State the type of reaction shown by equation 2. Now equation 2 is when calcium carbonate is decomposing into calcium oxide and carbon dioxide. So it is breaking down, decomposing. So the equation is thermal decomposition. The type of equation is thermal decomposition. Explain why the reaction in equation 3 can be described as acid-base reaction. Acid-base reaction. The equation 3, let's see what is equation 3. Now, in equation 3, we have calcium oxide and silicon oxide. They are reacting with each other to form calcium silicate. Now, if we see it carefully, then calcium oxide is a metal oxide, which is a base, and silicon oxide is an acidic oxide. It's a non-metal oxide acting as acid. So, here, point to be noted that calcium oxide is a metal oxide, which is a base, and silicon oxide, SiO2, is a non-metal oxide. And this non-metal oxide is an acidic oxide. So when base reacts with acid, it gives a salt, which is calcium silicate here. So that is why this reaction is acid-base, which is used for the removal of impurity in the form of slag. So here we'll write that calcium oxide is a basic oxide and silicon oxide is an acidic oxide. So that is why it is an acid-base reaction. State the chemical name of silicon oxide. It is called calcium silicate. The common name given to calcium silicate when it is formed in the blast furnace. Sorry, this one. The chemical name of SiO2. SiO2 is called silicon 4 oxide. The common name for calcium silicate is slag. Aluminium cannot be extracted from its ore using a blast furnace. State why aluminium is not extracted from its ore using a blast furnace. See, aluminium, in the reactivity series, aluminium is present above carbon. In the blast furnace, we are using carbon to reduce iron oxide and get iron. So iron is present lower than carbon in the reactivity series. So the elements which are present after carbon in the reactivity series, they can be extracted easily by carbon. And as we know that aluminium is present above carbon, so its reactivity is more than carbon. That is why it cannot be extracted by using reduction by carbon. So why aluminium cannot be extracted? Because aluminium has more reactivity than carbon. Name the process used to extract aluminium. Now, the higher reactive elements which cannot be extracted by carbon, they can be extracted by passing electricity. So, the process is called electrolysis. Both iron 3 oxide and aluminium oxide contains metal ions with a charge 3 plus. Write the electronic configuration of an aluminium ion. Now, aluminium has atomic number 13. So, its configuration will be 2, 8, and 3. This is the configuration of aluminium atom. But once the aluminium 3 ion is formed, it has lost 3 electrons, so its configuration becomes 2 and 8. Deduce the number of protons and electrons in an Fe3 plus ion. Now, Fe3 plus, if we see the periodic table, Fe has 26 protons and it has 56. 56 is its mass number. So here they're asking us about the proton numbers. So proton numbers are 26. Electron numbers, as it is an ion, so it has lost 3 electrons. So from 26, it has become 23. Next question is the elements in group 7 of the periodic table are known as the halogens. Halogens can form halide ions. Identify the halogen with lowest density. So the halogen with the lowest density, the smallest size is fluorine, because fluorine is the lightest in weight and has the smallest size. State the appearance of bromine. Bromine is a red-brown liquid. Use the periodic table to give the symbol of halogens with the highest atomic number. Now, if we see the periodic table, then the halogens start from fluorine, chlorine, bromine, iodine, astatine, and then we have an element which is called tennessine. So, tennessine is also a halogen. Here we'll write the element with the highest atomic number, and we have to write the symbol, so Ts. Deduce the number of occupied electron shells in this atom. Now, as this atom is a halogen, and halogens are present in group number 7, the group number 7. But the number of occupied electron shells, this tells us the period number. Like whatever period number the element is present is in, it tells us the number of occupied electrons. So tennessine is present in period number 7, because there is one first period which contains only hydrogen and helium. This is period number 1. Then fluorine is in period number 2. Chlorine is in period number 3. Bromine, period number 4. Iodine, 5. Astatine, period number 6. And tennessine is present in period number 7. So, 7. Bromine molecules have covalent bonding. State what is meant by the term covalent bonding. The covalent bonding is the force of attraction between the pair of electrons shared between two atoms. So, it's the force of attraction between the shared pair of electrons, between two atoms. So that's the covalent bond between the shared pair of electrons. You have to write this thing. This is very important. To get the marks, you have to write that it is formed between the shared pair of electrons and between two atoms, because in covalent bonding there are two atoms, at least two atoms, which come together, overlap their shells, and they share at least a pair of electrons, one from one atom, one from the other atom. These are the least possible thing for covalent bonding. So between the shared pair of electrons and the shared pair of electrons between two atoms, these 2 points are compulsory to get the 2 marks. State one halide ion which bromine molecules can displace. Now, as we go down the group in halogens, their reactivity becomes less. So bromine molecule is present down, and after bromine, there is iodine. So bromine can displace iodine very easily. It can displace astatine also. It can displace tennessine also. The elements which are present lower than bromine, bromine can displace all of them. So here we can write that bromine can displace iodine. It can displace astatine. Or you can also write that it can displace tennessine. Okay, but here you have to note down one thing, that you have to write about the halide ion. So we'll convert this iodine into iodide, tennessine into tennesside, astatide, like this. Explain why bromine can displace this halide ion. Bromine can displace the halide ion because bromine is more reactive than this ion. Name a halide compound which can be used to detect the presence of water. So, a halide compound which can detect the presence of water is cobalt chloride. So, we have this test of the presence of water that we will take blue cobalt chloride paper. We have blue cobalt 2 chloride, and it turns from blue to pink in the presence of water. So cobalt chloride paper, in hydrous cobalt chloride paper, it's blue in color. It's blue in color, and in the presence of water, it turns into pink. This is a test for water. So remember, cobalt chloride, anhydrous cobalt chloride. And this question is of 2 marks. So 1 mark is for writing anhydrous. Second mark is for writing cobalt chloride. Then we have to complete this dot and cross diagram. Dot and cross diagram for the calcium chloride. Now for calcium, it has 20 electrons, 2, 8, 8, 2. It means it loses these 2 electrons, last 2 electrons, and get 2 plus charge. So here in calcium, we'll draw the third shell with 8 electrons showing with the cross. Here like this. And as for the chlorine atom contains 17 total electrons, 2, 8, and 7. So it means chlorine will gain 1 electron and get 1 minus charge. Each chlorine will get -1. And in chlorine's third shell, we'll draw total 8 electrons, but 7 electrons of chlorine, indicating by circle, by a dot, and 1 cross, which is of calcium. So that's 1 chlorine, and then we have another chlorine. 7 chlorine's electron and 1 electron of calcium. So these are chloride ions, 2 chloride ions and 1 calcium ion. Aqueous lead ions are added to aqueous chloride ions. A white precipitate of insoluble lead chloride is formed. Name a lead compound which can be used in this reaction. So to form lead chloride, we have to use any soluble salt which contains lead in it. Any soluble salt. So here we can write lead 2 nitrate. Very easily we can write nitrate because all nitrates are soluble. So you can write nitrate with the metal. All nitrates are soluble. So that's a simple trick that if you want to prepare an insoluble salt, then with the metal, if they ask you a question which is normally asked, so with lead or with any metal, you can write nitrate because it's soluble. Then you have to write the ionic equation for this reaction. Now, ionic equation for this reaction will be, because we have to make lead 2 chloride, so we will write lead 2 plus 2 chloride ions, and they will give lead chloride, PbCl2. We'll write the state symbols also. We have to include state symbols. The ions are always aqueous, and lead chloride is solid. Name one other insoluble chloride. We have to write insoluble chloride. So all chlorides are soluble. All chlorides are soluble. If you know that except there are, what are the exceptions? All chlorides are soluble except the chloride of lead and silver. So lead chloride is written here in the question that it is insoluble. The second will be silver chloride. So we can write silver 2 chloride or just silver chloride. Okay, these are the two parts of the question, two questions. We'll do the rest of the questions in the next video of this paper, the next 3 questions.